Today we're going to be talking about how does current affect light bulb brightness. So first of all, just current has a direct effect on light bulb brightness because the more current there is, that usually means a brighter light bulb, and that happens because the light bulb converts electrical energy into light and heat. The brightness also depends on the power of the light bulb, so we can use the power equation to figure that out. And then for resistive bulbs, like the iridescent ones, like more current heats the filament more, so they glow brighter. And the more current means the more electrons are flowing through the filament. And then as the electrons move, they collide with atoms in the filament, which causes it to heat and then emit light. So overall, we use light bulbs in our everyday life just to help us see. And so what we don't realize is how each light bulb can have a different brightness. So today, we're going to learn more about light bulb brightness and how the current can affect the overall brightness of the light bulb. And we do have two equations that are very important when we're talking about current and light bulb brightness. So the first one I mentioned was the power equation. So it's going to be power is equal to voltage times current, and we can use that to find just the power of the light bulb, which can help us find the brightness. And then the second one we use is going to be Ohm's law, which is current is equal to voltage divided by resistance, and we use that one to help us find the current, and that's going to help us find the light bulb brightness. So to start, I do have this problem that kind of helps us to figure out just like kind of like an everyday situation. So we have just a 12-volt battery is connected to a light bulb with a resistance of 6 ohms. And now if you think about it, this can just kind of be like an everyday light bulb, like just connected, everyday light bulb, resistance of 6 ohms, and a 12-volt battery. So those are going to be the important starts for us with those. So our first kind of question then is, what is the current flowing through the bulb? So what we're looking to find here is that current. So to find that current, we're going to use the Ohm's law. So using the Ohm's law, it's going to be current, which is this I, which is equal to then voltage divided by resistance, which is the V over the R right here. So we have that the voltage is 12, so we have the 12V right here, and then the resistance of 6 ohms, which is that 6 ohms right here. So we end up getting 2 amps for the answer here. So 2 amps is the current that's flowing through the bulb. So the second question is, how much power is the bulb using? So we're going to use the power equation that I mentioned. So we have P power equal to current I times voltage right here. So since we found the I, the current from the last question, so we're going to take that 2A and plug it in right here then. So 2A is the current, and then the 12 volts, we have 12 volts from the equation up here, so the 12-volt battery, that's our voltage. So then we get 24 watts for the power here. So that's how much power the bulb's using. We get to our last question. If we replace the bulb with one that has 3 ohms resistance, how does the brightness change? So this one, we're going to start with we're going to start with our ohms right here. And we're going to go 12 volts divided by 3 ohms. We're using the 3 ohms from here and the 12 volts just from our original equation. And we're going to get 4 amps as our answer here then. But for this one, trying to find the brightness change, we're going to plug the 4 amps into our power equation to try to find the power. So we use the 4 amps from this equation here, and then we use the 12 volts just from our original question, and we end up with 48 watts as our power for the 3 ohms resistance. So the brightness changed in this one. We have a brighter brightness with the 3 ohms resistance, so resistance kind of can affect the brightness of the bulbs as well as the currents.